Hey everybody. So yeah, we will get started here in just a couple minutes. So hello Queen Bee. I was just oddly enough thinking about you. I was like, I wonder if she'll be there. So it looks blurry on my end. Maybe just my internet connection is really slow, which is certainly possible. So I hope it is streaming better for you all. It looks like if not, I'll even just kill the camera and hopefully that'll help a little bit with the streaming quality because I don't think my face really adds much to the, well, maybe a little bit. It's nice to see expressions and see people. Why not? So hope everyone's Saturday is going okay. So again, if you're hopefully, well, it doesn't matter. If you are, if you're just joining us now, this is what, day 4, day 5, I don't know, of that algebra review. So what I'm going to talk about again, I guess I should wait. Maybe I'll wait till 11 just in case somebody shows up at the last minute to rehash it. It doesn't matter, we'll rehash it again. We're going to finish our domain questions, and then we're going to jump into those graph transformations, which tends to give people a little bit of difficulty. So I also, too, is anyone watching who is going to take calculus? And maybe like soon. I'm just kind of curious. If not, I probably won't talk about what I was going to talk about. If so, this is supposed to be a preparation for calculus. But again, anyone can watch it. So if you're just here for the algebra, I'll just do the algebra. If you are taking calculus, maybe it's worth taking a few minutes. So, hey, Phaser, good to see you too. All right, I got my. There was one other person that was joining us. Calculus 1, 2, 3. Okay, you were not. I didn't think Queen. I didn't think any of you were, right? None of you. I think you were all just like. Some people were here just kind of learning, so that's cool. Then maybe we won't spend time on it. It doesn't matter. It does matter, but we'll save it for another day instead of spending time on it. So okay, so I think maybe again. So I'm going to go through it a little bit faster because, again, I'm trying to, okay, yeah, okay, awesome, thank you. Like, this is good for me to note, Tet. This is, I took out, yeah. Yeah, and like I said, if you don't use it, you lose it. So I warn people, they're like, no, I'll be okay. It's calculus. I took calculus 1, and I'll be fine. And then the algebra again kills them. So, good. Welcome. I think maybe this is the first time I've seen you. So welcome here. For any of you that are interested, I may do a trig review. I thought about doing a preview of calculus. One time when I taught pre-calculus, instead of doing the last bit of material, I actually just instead did a preview of calculus because I didn't think what the school had structured was really important. And I had students actually come back and say, wow, that preview of calculus really helped me because we did like the, it kind of got them through like the first 2 or 3 weeks, like the big concepts. So that was nice for them. A lot of them like that. So I thought about doing that. How do I know about Pumbicalio? Because I am a hip, cool guy. That's how. So I'm big into music, my friend. So that's it. That's one of my passions is music. So yeah, so trig, so we can do a bunch. I don't know if people will watch it. Another thing too, I don't know, tell me if this is crazy. I thought about even just like through the week or on the weekend for like an hour or two, just like literally hanging out and having like office hours, quote unquote, and just like people could drop in and be like, hey Patrick, are you available? I've got a question on trig. I'd be like, yeah, sure. Or I've got a question on calculus. And I'd be like, yeah, sure. So I don't know. We'll see if that makes sense. But okay, anyways, let me check out my questions. So we were doing the last bit of domain. Let me at least do one last domain question. You all tell me if you need to see any others. Because I think we went through them pretty quickly, and I said, I think we've really got most of the ideas here. But let me do one more, just in case, because this last one does involve quite a few things. So I'll do one last one, and then we'll go on to graph transformations. And again, I'm going to spend a little time on graph transformations because it's really useful to know A, in general, but B, especially in a calculus course. If you're good with graphs, it'll make your life so much easier, I promise. I tell people, a lot of people say, no, I'm not going to learn them, and they end up paying the price. Down the path, something, so would I do a live stream with Calc 3? Potentially. It just depends on if the interest is there. I mean, certainly there's gobs of videos. So, okay, so let's find the domain. Okay, so again, remember we were kind of thinking like, I kind of think about in terms of value, like what values of x are either good or bad, and then I either keep them or throw them away. So in the sense I'm starting, right now I'm starting with all numbers from negative to infinity. That's my potential domain, and I'm trying to figure out what numbers do I want to throw out. So in this case, I look at, I think, well, the first thing I recognize a lot of things, right? I think, well, I've got a fraction. right? There's a fraction in there. That seems relevant. I see this natural logarithm. Well, that's a type of function. That's important. But inside of there, I have this thing that's squared minus, okay, well, that seems relevant too. And then I've also got the square root. There's lots of things going on to focus in on. But really, to start with, I'm just looking for my variable x. I'm looking for my variable x. And I'm thinking, where does it live in regards to my fraction? Well, it's in the numerator and the denominator. So I kind of have to start looking at both of those things. I have to worry about, I start looking at them individually. So the thing is, I'm looking at the numerator individually, and I'm looking at the denominator individually. So I'm really thinking is, are there any restrictions, or really what's the domain of, I'm going to think about what's the domain of the function, the natural logarithm of x squared minus 100. So I want to think about that one, and then I'm also going to think about, what's the domain of the square root of x minus 8, those two things. What would I need to solve? So maybe we'll start with the denominator first. Whoops. Maybe we'll start with the denominator first. What type of equation or inequality would I need to solve? So what equation or inequality could be less than, greater than, do I need to solve? In regards to that denominator, the square root, so what values would be acceptable to get in the denominator? That's really what I'm thinking, right? Well, there's a couple things, right? I don't want the denominator of a fraction to equal 0, so that would be bad. But we also know we don't want a negative number underneath the square root. So I know that 0 is out, that's bad. And we also know that negative numbers are out, that's bad, right? We don't want a negative number underneath the square root. So I think you've almost got it, Phaser. So I think x minus 8, it looks like you have greater than or equal to 0. So let me phrase my question more correctly, because I may have said it wrong. So okay, yes, okay, good. Wait, not 0, I agree. So if you're just kind of thinking about the square root of x minus 8, I would agree you could have equal to 0, no problem. But yes, you are, like you're saying, in the context of this problem, right, we don't want it to equal 0 either. That would be bad. So in this case, we just need to sort of get the good values of x, the value of x that are in the domain, that work for the denominator. We would need the values, this just says what's underneath the square root, right, which is x minus 8. We just need values that are larger than 0. Well, to solve that, we can add 8, add 8. So this says that x has to be greater than 8. So already I know, so here's 8. I'll put an open circle because we can't use it. And then everything greater than that is what works so far. That's what works so far. So that's going to be the restriction on the domain. But now I have to go back and think as well, are there any restrictions from the numerator? So I'm going to go back and I'm going to think about, I'm going to do the same thing, the natural logarithm of x squared minus 100. So the same question. First off, are there restrictions on the domain of a logarithm function? And hey, Pot, it's very nice. You're so kind. King, I am not, but I will. I appreciate the kind words. So, my pleasure. So, it's kind of the same question for this next one. If there are no restrictions, maybe who cares? Maybe it doesn't matter. So, okay, yeah. So remember, I agree with Phaser here. So remember a logarithm. If the base is larger than 1, which is typically what we see. So here's a logarithm where the base is bigger than 1. This has a domain from 0 to infinity. So in general, it says whatever is inside of the logarithm, whatever's inside of the logarithm, well, in that case, x squared minus 100 is inside of the logarithm. I don't care what's inside of there. Whatever is inside of that set of parentheses, boom, it's going to get copied down. It could be anything. I think, when is that greater than 0? It has to be greater than 0. That's what this says. Okay. So again, I'm recognizing there's a variable inside of those parentheses, right? You know, if it was just natural logarithm of 5, that's just a number. Okay, so now I've got an inequality to solve. So again, now this is the thing, right? This is again, it's just a different. Now it's back to an algebra question we've done because, you know, again, I did these earlier, and that's why, because it ties into these. So the question is, you know, now if you're sitting there on your calculus, you know, or pre-calculus or algebra question, test, quiz, test, and they say, you know, how do you solve that inequality, x squared minus 100? So now we have to remember how to solve these, right? So this is just another thing we pull out of our toolkit. So recall what I would do. So again, I'm going to make a number line, but this only goes with the domain here. Don't get it confused with what I did here. This is not the same one, okay? So I'm just thinking about the domain of this natural logarithm of x squared minus 100. Well, what I'll do is instead, I solve the corresponding equation. And you could solve x squared minus 100 equals 0 in a couple different ways. You could add 100 to both sides, take the square root. I'm going to factor it just to remind you about factoring. That's x minus 10 or multiplied by x plus 10 equals 0. Again, notice negative 10 multiplied by positive 10 is negative 100. We want that. And if we add negative 10 and positive 10, we get 0. And that's the coefficient in front of x. There's no term involving x in our expression x squared minus 100. Well, if we take each of these and set it equal to 0, we'll get x equals 10 as a solution, and x equals negative 10 as a solution. So negative 10, there's positive 10. Okay, that's where it equals 0. But again, I want to get values that are greater than 0. So I know those don't work. And recall at this point, this is where we have to take test points. Yay, okay? We have to take test points. So I could take a point from this interval to the left, something smaller than negative 10. Maybe I use x equals negative 20. Something from the middle, maybe I use x equals 0. Excuse me. And something larger than 10, maybe I use x equals positive 20. And then the idea is I plug each of those test points into that inequality and see if they work or not. Okay, so I agree. It looks, so let's see. So I agree that it looks like something large. So Phaser's saying take the set of x. He's saying take x's that are 10 or larger than 10. And I agree with that. And let's even test that. So larger than 10, Phaser's looking at this interval over here. So if we test, say, x equals 20, let me even write that, x equals 20, you would get 20 squared minus 100. And again, I'm asking myself, is that greater than 0? I'm trying to satisfy that inequality. Well, 20 squared is 400, right? 400 minus 100. That's definitely greater than 0. So those values would work. So I agree with the. And again, I'm starting at 10. I tested with 20. I started with 10. For those of you that watched the other day, I screwed up my interval, even after saying don't do it, and somebody had to correct me. So do be careful. The interval does start at 10 in this case. So 10 to infinity, I know that's good. But what if we test, say, x equals negative 20? So I'm testing that left interval. Well, then I would have negative 20 squared minus 100. And the same thing, is that greater than 0 if I plug in negative 20 and I square all of that? Well, yeah, because negative 20 times negative 20, that's still 400, right? That squaring gets rid of the negative part. So actually stuff over here is going to work as well. And you can check stuff in the middle doesn't work. Okay. So I think Phaser maybe is giving us the final answer is what Phaser is doing. So, okay, so this is what I think. It's like having two kids that are happy, right? You've got two kids. You know, kid number 1 is up here, right? For kid number 1 to be happy, it only wants things that are larger than 8, right? Give me something that's larger than 8 and I'll be happy. Fine, kid. Okay, I'm going to try to make you happy. Now, the other kid, right, the other kid is your natural logarithm function. And natural logarithm function says, hey, you know, dad, Patrick, Papa Patrick. Anything bigger than 10, it either has to be bigger than 10, that'll make me happy, or it has to be smaller than -10. That'll make me happy as well. Well, you want to make both kids happy. Suppose you're going to give them the same thing, right? You want to make both kids happy. Well, even though something smaller than -10 works for this kid, right? The other kid ain't going to be happy. So you're just you're thinking, where is the overlap of these two domains? So the first domain, it says 8 or larger, I'm good. But the second domain says, no, you have to actually restrict that further to stuff larger than 10. So the final solution would ultimately be, the domain would be from 10 to infinity. And again, this is interval notation. This is interval notation. And the way that Phaser has it is also correct, at least in my experience in the calculus course, unless you're taking something pretty technical. You tend to see interval notation. This other one is what's known as set notation. Both are 100% correct, 100% valid, unless someone's specified, use interval notation, use set notation. They shouldn't care. So, okay, so that's the domain. So it turns out, that logarithm ended up being so restrictive, it sort of dictated things. So any questions on that one? If not, I'm going to jump on. So I think that does kind of combine the ideas that we were doing, right? We were sort of looking at the numerator, we were looking at the denominator. You end up typically setting up some sort of equation or inequality for each one of those. And then it just, again, turns into like two separate problems. How do I solve an inequality? How do I solve a quadratic equation? It's like, it could turn into it. It just depends on what's there, is what I'm saying. And again, soon, for those of you that do go into calculus, the numerators and denominators aren't just going to involve algebraic functions like we've been doing. It's going to involve trig, right? You're going to see stuff involving sine and cosine and tangent and secant and cosecant and cotangent. And they're going to be squared and cubed and square rooted and all that stuff. So that's coming too if you're taking calculus, unless you're taking calculus without trig, which is possible, but it really limits what you can do, I would say. Okay. Sorry. Okay, so I'm going to skip past I'm going to skip past the rest of the domain questions. Oh, that's interesting, Phaser. Yeah, I mean, why not? Write it in both. So I know, like, for example, again, that I always taught out of the James Stewart calculus texts, at least here in the USA. His textbooks have to be by far #1. He's got a cool house for anybody that's never looked at it. He passed away quite a while ago. Not quite a while. 5-10 years. But almost everything he does is interval notation. So the thing I don't like about interval notation is that, right, this looks like, suppose it was 10 to 20, right? That looks very much like a point on a graph, right? It looks like a dot. So that's my only gripe about it. But anyways. Okay, so I'm going to skip the rest of the domain questions unless somebody has a big issue with that. And then I'm going to go on to graph transformations. And I'm going to try to go through these relatively somewhat quickly. If you have never seen graph transformations whatsoever, in my experience, when you teach them in an algebra course, when I do a review for them physically in front of a class in a calculus course, people don't like it. Hey, Manhattan, Ethiopia, awesome. So cool. Video on partial implicit derivatives. I'm pretty sure I've done a video on partial implicit differentiation with 3 variables, or I'm almost positive. I think I've got one with UVW. You got to dig. I'm pretty sure. So go look. But yeah, Ethiopia, cool, nice. Okay, so let's do graph transformations. I'm going to go through these quickly. If you've never seen them, people struggle with them, was the point I was trying to say. Calculus, people see them again, they're like, they still don't like them. So if you go to calculus, please, 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 if you do your friend Patrick one favor to make your life easier, know how to do no basic graphs, no graph transformations. I swear it's like it's by far the shortest amount of time that you can spend on something that will give you the best improvement in your grade, I think, in an algebra class. I honestly, that or some basic trig stuff. Okay, that's my pearls of wisdom. Okay, so let's go through a couple things. So for graphs, you should recognize, be able, and I'm going to sketch them real quick in some cases. So be able to recognize. You should recognize that something like 2x plus 4y equals 8. So maybe I'll give you some examples. Or ax plus by equals c. This is going to be the graph of a line. You should recognize, hey, that's the graph of a line. You know what graphs of lines look like. Likewise, you've seen quadratics, right? You should know that that's going to be a parabola that either opens up or it opens down, depending on whether the coefficient a is positive or negative. You'll be expected to know that graph. You should certainly know the graph of y equals absolute value of x. You should definitely know that one. Recall that that one's that v, where the tip is right at the origin. And again, you can move it around. Absolute value ends up being important. You can use it just for some interesting applications. And then again, it represents distance and magnitude. So that's kind of some of the basic applications of it. So you would want to know that one for sure. You would want to know y equals the square root of x. But in addition, really any even powered root. The 4th root of x, the 6th root of x, etc. And again, that's the same thing, right? Is x to the 1/2, x to the 1/4, x to the 1/6. So they may give it to you in radical notation. They may give you exponent, this fractional exponent. And in all of those cases, it roughly looks like that. So x, y. So there's y equals, I'll label it the square root of x. And notice if you plug 1 in, you get 1 out. So a root function will go through 1, 1, as long as it's not tweaked or shifted or literal change, obviously, is what I'm trying to say. Okay, root x. That's the same thing, square root, 4th root. Now, you should also know what a cube root function looks like, or a 5th root, or a 7th root, etc. Now, it looks very similar on the right side. It still has that shape to it, like a square root or a 4th root, etc., etc., etc. But you can take negative numbers of odd-powered roots. So the domain, right, you can plug in negative numbers. You're going to get negative numbers spit out. And that's roughly what it's going to start looking like. And I shouldn't make it, it looks like it's flattening out like it has an asymptote. It definitely doesn't do that. It's not going to flatten out. It's going to slow down in how quickly it grows. That's certainly true. Well, how quickly it grows this way. And so that would be the rough shape. Also, too, we did x squared. That's going to be the same thing. So let's go back and point that out, that comparison too. So this is y equals x squared. In general, if you have something like x to the 4th, x to the 6th, x to the 8th, if that's the highest powered in your polynomial, it's still, we don't call it a parabola anymore, but it still has that basic U shape to it. You should know those. All right, so that's even powers of x. Well, Patrick, what if it's odd? We know if it's to the 1st, it's a line. So what if it's odd? What happens then? Well, it kind of looks like the parabola on the right side. Right? We still have that parabola shape on the right side. It's not a parabola, though, because it's raised to a different power. But again, though, we can take, if I plug in a negative number, I'm going to get negative numbers out. So now they're just going to spike down on that side. So again, don't think I will get to those as well. Absolutely, those are good ones. Phasor, I will talk about those. Thank you. Thank you for reminding me, actually, because I think I would have forgotten them. Oh, thanks, NC. Yeah, I thought about this too, man. What? Because I think I missed the boat. I don't think uh, I would have ruled the world if I could have done live streams back in the day. So yeah, um, but so okay, you should definitely know those. Trying to think what else here. Okay, so let's do phasors. Oh, what I was going to say is too, you can reason these out as well. It's not like you're memorizing a lot of these. I mean, to me, I like it makes sense, right? X to the third should look like that. And the thing I always tell people, if you forget, plot points, it seems like everyone on Earth that I talk to seems to forget that they can do this, right? You make your little chart, X, Y, you start plugging in values for X, and you get out values for Y, and then you get points, right? And then you go start plotting those points, and then you play connect the dots and whatever, and then you got your graph. So you can always do that stuff if you forget. Okay, so let's do like phasor said. Let's look at, say, y equals 1 over x. But this is also true for 1 over x to the third, 1 over x to the fifth, 1 over x to the seventh, etc. The same pattern holds true. Well, notice, let's just focus it on 1 over x. Notice if you plug in 1 over 1 is 1. Okay, so that point is going to be on the graph. I can do that one. And again, notice if you plug in larger and larger values of x, right? 2, 3, 4, 5, 6, 7. The values you're going to get out are going to be 1/2, 1/3, 1/4, 1/5, 1/6, right? They're going to keep getting smaller and smaller and smaller and closer to 0. It's always going to be something positive, right? If you're at x equals 1 million, it's going to be 1 over 1 million, which is pretty small, but still positive. So to me, the graph should get closer and closer to 0 as we go this way. And the fact that those values, the y values, are leveling out and getting closer and closer to 0, recall that we call that line a horizontal asymptote. So we would say the line y equals 0, or equivalently, the x-axis is a horizontal asymptote. Now, the question is, what happens in the middle? Notice this is going to be undefined at 0, right? There's not going to be a point at x equals 0 because we would get 1 over 0, so that's bad. And it's going to turn out, if you plug in numbers closer and closer to 0, it's going to spike off to infinity. And if you do it with the negative numbers, it's just going to be almost the same y values, just a reflection. So that would be the graph of 1 over x, last but not least, and then let's do some graph transformations. 1 over x squared, 1 over x to the fourth, etc. And then let's get out of here. It still looks like this on the left side. Excuse me, the right side. It's still going to look a lot like that on the right side. So it still has that shape, right? But now the idea is if I plug in negative values, right? If I plug in negative numbers, since I'm raising them to an even power, I'm going to get a positive y value out. So in that case, it's just going to reflect. So that would be your graphs 1 over x squared, 1 over x to the fourth, etc. Okay, thrilling stuff, yes? Not particularly, but it is useful. So, okay, do I need any others? I don't think so. So let's do some of these. I think this is everything we need. It looks like it. So I'm going to go through these quickly because I have a few things to do. One of those involving a nap at some point. Okay, so when I do these, I like to do these in pieces. Maybe I do them all at once. If you glanced, you may see the final picture. Yeah, I struggled with pre-calcs. Yeah, people, it really bothers people. Vivek, I'll see what I can do for you there. But it's algebra for now. My apologies. So I try to do these a piece at a time. And the first thing I'm going to graph is I'm going to graph y equals the square root. First I'm thinking, do I know the graph of square root of x? That's really the first thing I'm starting with. And then I'm going to graph the square root of x plus 3. And then from that, I'm going to take that graph, and I'm going to graph the one I actually want, the square root of x plus 3 minus 4. So I'm kind of doing it in, like I'm kind of doing, okay, this part does this, and then this next part will do this, and then this next part will do this to that graph, and then boom, I'm done. That's kind of how I go through it in my head. So the first thing I'm going to do, recall, okay, so I'm going to write it generically. So if I have the graph of f of x, and I replace that with f of x plus some number, what that's going to do, this is going to shift the graph. It's going to shift the graph, it's going to shift the original graph, k units. What's the best way to say this? We'll assume k is greater than 0. This is going to shift it k units to the left. Does the order matter when there are multiple transformations? It depends, is the answer. Yes, in general, yes. In general, yes, it does. You do need to be careful. I typically start, if it makes sense, like inside out. So to me, I'm kind of starting with like square root of x. That's sort of the graph that I'm starting with that I'm going to transform, right? That's my first thing. And again, it's not a good explanation, maybe. I'm trying to think of a better way of doing it. But to me, the most inside thing, right? You know, would I do this first? Is that more inside, or is this part more inside? And you should, like in this case, it won't matter. Okay, so in this case, it won't matter. That's the thing. When you start doing like compressions and stretches, you need to be careful. So like the very last one, 57, is by far going to be the one that'll give people the most trouble, I think. Okay, so the idea is, in this one, so square root of x looks something like this. And maybe I'll even, again, label a point. So this is 1, 1. Maybe I'll label 2 points, in fact. So there's 1, 1. Let me make my graph a little bigger, just to illustrate again what's happening nicely, hopefully. Okay. So again, forgive my poor graph. So there's 1, 1 again. So this is just y equals square root of x. And I'm going to think about what's happening to the shift. So there's y equals square root of x. Notice if we plug in 4, the square root of 4 is 2. So that's going to be the point 4, 2 on the graph. So in this case, I want to think about, well, instead of graphing y equals square root of x, I'm going to graph y equals the square root. We would say the square root of the quantity x plus 3. I just say the square root of x plus 3. It's still not always clear to me. So to me, the kind of thing I think is this is on the inside, right? It's still inside the square root, so I have to be careful. So it's on the inside, and what I've done is, imagine, right, if this was my function, if f of x equaled x, that's this part, everywhere there's an x, I've replaced it with x plus some value. And that's what I've done. I've replaced x with this value of x plus 3. Okay, so I've replaced that. It's on the inside. So even though I see a plus 3, I know it's going to shift it left or right. This is where I have to be careful. Left or right. It's going to kind of feel, if you just think about the sign, it's going to feel opposite. To me, it feels correct because it goes the way it should. But what I'm saying is, even though you see a positive 3, this is going to go to the left 3 units. Okay, so I could take this point. Notice it originally set at 0, 0. If I move it to the left 3 units, that's now going to be at negative 3, 0. That point that was at 1, 1, the y value stays the same. I'm not changing the height on that y value. I'm just moving it 3 units to the left. So that's now going to be at negative 2. So that's the point negative 2, 1. And then that point that was at 4, 2, again, that y value is not changing. I'm just moving it 3 units to the left. So instead of x being at a value of 4, which is where it was originally, if I move it to the left 3 units, it's now going to be at an x value of 1. But again, the y value hasn't changed. So that almost looks like a line because my graph is so terrible. Let me try to, so let me draw the graph and then I'll label points. That'll be better. Okay, so we'll put it there. So we'll make this the point. We said that was going to be 1, 2, and we said this was going to be the point -2, 1. So again, that is this graph. So all I've done is taken the original and then move it to the left 3 units. So imagine that original graph is like rigid, like a piece of wire, right? You could just pick it up, yoinks, and then just move it 3 units to the left. So now the idea is if you have a function y equals f of x, if then I take that graph, and again, we'll assume k is greater than 0. Suppose I either add or subtract some number onto it. If I add k, it's going to move it up k units. And if I have a minus k, it's going to go down k units. So in this case, what I'm thinking is, well, now I've got y equals the square root of x plus 3. And I know that graph, right? That's this graph. That's what I just found. Okay, good. And then, well, what did we do? We tacked on this minus 4. So this minus 4 is going to move it down 4 units. So maybe I can even label that on the same graph just to compare them. So I'm just going to move now that graph down 4 units. So for example, this point that was at -3, 0, I'm going to move it down 1, 2, 3, 4 units. So there's now -4. And that point's just going to drop straight down. So that point's now going to be sitting right there. So this is now going to be the point, that would be what? The point -3, -4. It's just dropped down 4 units. And I could do the same thing for this point. It's just going to drop down. So the y-coordinate, instead of being at 1, if it moves down 1, 2, 3, 4 units, you're now going to be at -3. And then our last point up here at 1, 2, if I move that y value down 3 points, excuse me, down 4 values, it's now going to be up here at -2. And again, I'll try to make it, it's supposed to have that same root shape. My graph is a little cruddy, my apologies. But that would now be the graph that we want. So imagine again that rigid piece of wire that we had at the beginning. We just moved it to the left 3 units, and then we moved it down 4 units. What is the best book to learn integral calculus and advanced calculus? I don't think there is one, which is not the answer you want to hear. I used calculus. The textbook that I've taught from the most and the one that I've seen the most, again, is James Stewart's calculus text. And some people don't like it. I thought it was pretty good. It's not bad. It's certainly, and they're now on like the 10th edition or whatever. James Stewart. If you want a full-on textbook, I mean, there's nothing wrong with it. His books are pretty good. And if you looked for like, yeah, maybe Eric's got the right idea. If you look at some of the older editions, which are just fine, get like a used, 5th edition with a solutions manual for $15, and you'd be good to go. I mean, there's a lot in. That's how I taught myself. So. Okay, so that's all we're doing that one. Or as Eric says, go grab a Bible. Maybe get a Bible and maybe get them all. Get one of each and just to hedge your bet. Just to make sure. Okay, so let's do 53 next. Let's talk about that one. Okay. And again, I'm going to go through this one. So this one's got quite a bit more going on. So these are not definitely not ordered. Whoops, definitely not ordered in increasing difficulty. Just in case you're looking at them, it looks like I kind of jumped around or something. Okay, so here we want to graph negative 1/2 x minus 3 quantity squared plus 3. So again, what I'm going to do is I'm going to kind of do this in 3 steps. Technically 4 if you want to think about it. So the first off, I'm thinking, what graph am I going to move around? What graph do you think we would start shifting around here, you know? I didn't really say any other than James Stewart. There's one, I could go look. What's the guy's name? It's in there. Rogalski. I've taught from that one. I made a ton of videos for Macmillan. Rogalski. I think that's how you spell his name. I'm almost positive. I always put an O where an A should be or an A where it's supposed to be. What graph are we shifting here? Yeah, so x squared, good. So I'm thinking about y equals x squared. The calculus books by Rogalski are also good. I don't know if I ever taught Riz. I made a ton of videos, and it looked to me definitely on par with Stewart's. I didn't see any big difference. Yeah, parabola is the parent graph. Good. Okay. So that's, and you know, this is what I'm saying, right? If you don't know the graph of a parabola, plot points, and if you can't do that, then you're just going to be, you know, kind of be in trouble. So I'm going to think about this in 4 steps. The first thing, I need to know x squared. The first thing I'm going to graph is the quantity x minus 3 squared, and that's going to shift it left or right. And then I'm going to think about, I don't know why I keep switching all these colors, just ignore them. The next thing I'm going to think about is 1/2 x minus 3 squared. I'm going to think, oh, what does that do? And then I'm going to think, well, what does that negative do? What is that going to do to that graph? And then last but not least, I see this number tacked on at the end, and that's going to move it up or down depending on if it's positive or negative, just like the very last one we did. So if you peeked at my graph, you know, I would just, boom, there it is, because I've done enough of these, and, you know, that's why they let me be the instructor, right? But it's not trivial. I'm saying the only reason why I can do that is because I've done enough of them. So if it takes you multiple steps, you're in good company. It used to be me too. So take your time. Do what's necessary is what I'm saying. Okay. So we know what y equals x squared looks like. So now I've replaced x with x minus 3. That's going to shift it left or right. So let me ask you that. Does it shift it left or right? And it's going to have to do with 3 units. Does it go left 3 units? Or is it going to take the graph and shift it right 3 units? That x minus 3. And you can even compare, right, the original one that we had. So you could write it as plus negative 3. Yeah, you could certainly write it that way. So this would be x plus negative 3. So you could do that. So the way I always kind of thought, like if it's just inside of a set of parentheses, especially, that's visually where I'm looking. If it's inside of a set of parentheses or like a square root, that's when it's going to move it left or right, and that's when it's opposite. So in this case, even though I see a minus 3, it's actually going to take my graph and shift it 3 units to the right. So this point that was at 0, 0, it's now going to be at 3, 0. And I'm not going to label a ton of points like I did a second ago. You can certainly, the collective you can do that if you would like. Okay, so this is going to be the graph of x minus 3 quantity squared. And again, if you're not sure, if you're like, is this correct? I see this x minus 3. Does it go up? Does it go down? Does it go left? Does it go right? Pick one, right? Just pick one. If you have no idea, pick one. Well, is this correct? Plot points, you know, plot points. What if I plug in x equals 3 into this formula, right? If I plug in 3, what do I get out? Well, if I plug in 3, right, I would get 3 minus 3, or 0. 0 squared is 0. So that means 3, 0 had better be on my graph. And hey, yes, it is. 3, 0 is on my graph. So already I'm thinking, well, that's a good sign, right? If that point wasn't on the graph, I would be like, uh-oh, I've done something wrong. So you can always plot points and just make sure that you're doing things correctly is all I'm saying. Okay, so the next thing is, so now from that we're going to graph. So now I'm going to graph y equals 1/2 x minus 3 quantity squared. And maybe I'll kind of highlight this 1/2. So what is that going to do? Thank you, Vivek. I'm sure everyone here learning algebra will appreciate that. So, okay. So what is this 1/2 going to do to this other graph? Right? So I'm now thinking this does something. And I'm thinking, what does that do to this graph? Right? Which is what we just produced. Hey, Phaser's got it. Yes. And what I'm thinking is, like before, if you plug this in, right, you're getting some y value, right? You're getting the y value out. And now it's just taking all of those original y values and it's multiplying them by 1/2. If you take a y value, you're just chopping them all down, right? If you chop them all down, you're just squishing it. So maybe I will plot just a couple points just so we can see some references here. Okay, so yes, and let me write that. So this is going to be a vertical compression. Of 1/2. So let me plot another point. So over here at 0, notice if I plug 0 into this formula, if I plug in 0, we would get 0 minus 3 squared, negative 3 squared. I would be up here at 9. So you can check, does that make sense? On this graph, x minus 3 quantity squared, if I plug in 0, I would get 9. Well, if you think about the point 3, its original y value is 0. If you take 1/2 of that of 0, you're still at 0. That doesn't change. Now, this point on the y-axis, that was the point 0, 9. It doesn't move off the y-axis, right? It's still along the y-axis. But instead of being up here at 9, I've multiplied that y value by 1/2. So instead of being up here, instead of being up here at 9, I'm now at half that distance. So there's 9. Well, there's 9/2, right? Or 4.5. So that's going to be my new y value. And then it's going to still have that parabola shape, but now, instead of being a little more narrow, right, my bowl is a little wider, right? So that's the idea. Okay, so far so good. And now the next one I would do, I would think, well, from that, I'm going to graph y equals negative. Negative, negative, negative. That's the only thing that changes. 1/2 x minus 3 quantity squared. So what does the negative do to the graph that we just had? Right, so now this is the question. What does that do? How does that negative out front change? Well, again, think, right? Previously, you get some y value out on the original graph, right? There's some y value on the original graph, and it says whatever that original y value was, it says change the sign on it, right? That negative, it says take the negative of that, which is, well, if it was positive, it's now going to be negative. If it was negative, it's now going to be positive. So the effect that will have on the graph is exactly, again, like Phaser says, it's going to reflect everything about the x-axis because it's just changing the signs is what it's doing on those y values. Okay, so this is going to reflect about x-axis. All right. So that's just going to take that graph and reflect it. So again, I'm just going to take that graph. I'm looking right above it. So that point that was at 3, 0, well, if you reflect it about the x-axis, I mean, it's sitting on the x-axis. It doesn't go anywhere. But that point that was at up here at positive 9 over 2, it's now going to be at negative 9 over 2. So there's that. Yoinks and yoinks. And again, if you wanted to make a better graph, by all means, whoops, that's still positive 3, not negative 3. You could always make a better graph by labeling more points. Okay, yeehaw, what was the last thing we had to do? We had to add 3 to it. Holy moly. Okay, we're almost there. So now, last but not least, and maybe I'm just even going to put it on the same graph. Oh, I guess it doesn't matter. So we've got all that. What was it? Was it plus 3 as well? I should have used plus 4. Oh, well, what does this plus 3 do on the outside? So now I've got that plus 3 tacked on. What effect is that going to have on this graph that I just produced? And I know this is a lot of stuff quickly. Don't get me wrong. This is normally stuff that I would take probably a minimum of 2 weeks in a normal algebra course. Okay, so this plus 3, this is going to go back right to what we did a second ago. Right, we had that square root of x or the square root of x plus 3. We had this number on the outside. When it was a minus 4, yeah, exactly, Queen Bee. When it was a minus 4, right, we moved down 4. Well, we don't have a minus 4. In this case, we've got a plus 3. So exactly, this is going to move it up 3 units. So I'm going to graph this one in the same spot. Okay, so there was 3, 0. On my new graph, that's going to be at 3, 3. And this point that was at, okay, so negative 9 over 2, negative 9 over 2, that's what, negative 4.5. So if I add 3 to it, it's still going to be at negative 1.5. Or you can make that into negative 3 halves. Me, if it was a graph, since I've already used fractions, I would label it as negative 3 halves. I'm just writing them all in there to be, just to illustrate. So mainly the point I'm saying is, I want to know is the graph above or below the x-axis, just to get a slightly better graph. And again, by symmetry, I would know that if I go to 6 even, right, that's a point I didn't consider. By symmetry, I should be at a point over here as well. So, and then again, it's just going to have that shape to it. So again, my parabolas look terrible. They clearly do not resemble each other. The red and the blue one are supposed to be the exact same shape. So, oof. This is the problem with doing it by hand. But this red one now would be the graph. Y equals negative 1/2 x minus 3 squared plus 3. So my graph looks terrible. And as the kids say, skill issues. So that's okay. Sorry, important text here. I need to correspond with my airport passenger real quick. Because I don't know what time I have to be at the airport, which seems like a relevant piece of information. Okay, so that's all that's going on in that one. Okay, good. So if you have questions, slow me down, because I think really if you can do that one, you can probably do a lot of these as long as you know basic graphs. There's really only one other concept on this sheet, I think, that we didn't talk about, and that was compressions. So I'm going to go ahead and start writing because there's a delay. If you have questions, definitely put them in the chat, and I will read it here in half a second. So this one's actually pretty easy. So I've got 1 over x plus 2. I'm just thinking about the graph. This looks a whole lot to me like the graph of Okay, y equals 1 over x. And sometimes they'll call that the parent function. That's usually what I've seen in textbooks. They'll say graph y or graph f of x equals 1 over x plus 2, where the parent function is 1 over x, or what is the parent function? Okay, so there's 1 over x. So now what am I doing? So okay, so this is where it all comes down to. I see this plus 2, right? I see that, and I'm thinking, is it up? I think it's one of these, right? It's either up or down 2, or it's left, right 2. I'm thinking it's one of those, right? I got it narrowed down to 4. And now I'm thinking, which one of those 4 is it? And okay, so Queen Bee says up. Does anybody agree or disagree with that one? And we'll put the correct one over here. What software is this? This is a software called Notability. It's just an app on iPad. So Apple Store. There's a Notability and there's one other one that's pretty equivalent. What's it called? You should be able to figure it out with the Google search. That was the last problem. What happened? Did I do something weird? Okay, I don't know. I'm not sure that. Okay, so anyways, on this one, so notice I'm replacing the x with x plus 2. So that's what I've done. I've replaced x with x plus 2. That's really what I've done here. So this really goes back to this graph shifting of left to right. I think maybe the first one was the easiest place to see it, right? I started with an x, and then I replaced that x with an x plus 3. So in this case, yeah, no problem. So in this, it's very inexpensive too, Induced. If you go look at it, it's very inexpensive software. So I've replaced the x with the x plus 2. So actually, what this is going to do, even though I see a plus 2, this is actually going to shift it again to the left 2 units. And another way that I think about it is, if you look at this original function, 1 over x, what value of x is going to make it undefined? Right? This is going to be undefined. Or again, like what's the domain is what I'm thinking about. If I know where it's undefined, I know whatever's left is the domain. So knowing where it's undefined is equivalent to asking where is it. Asking where it's undefined is equivalent to saying what's the domain. Well, this is undefined at x equals 0, right? Because if you plug in 0, you're going to be dividing by 0. And if I look at this one, f equals 1 over x plus 2, well, this one, where is it going to be undefined? Well, this is definitely, to me, looks like it's going to be undefined if you plug in -2 into the denominator, right? If you plug -2 in, you're going to get 0 in the bottom, and that's bad. So here's the line x equals -2. So already to me that's saying, it didn't shift it up, because if it shifted up, that original, that place where the domain isn't there, this line, we call that again in this case it's a vertical asymptote. If it just shifts it up, right, that vertical asymptote shouldn't move either. But that vertical asymptote actually got pushed over. And that's what's going to happen to the rest of the graph as well. So let me take a point, for example. If I plug 1 in here, I'll get 1 out. Well, I'm still at that height of 1, but if I move it to the left 2 units, if I move it to the left, I'll go to 0 and then to -1. So here's -1, 1. It still has that same shape, though, as before. It still has that same shape. And again, notice if you plug in 0, you would get 1 over 0 plus 2, which is 1/2. So that would be the graph. It would just be, I should do the other side too. Boom, it's down here as well. So both sides, just imagine taking that whole graph and just sliding it over 2 units, and we got it. All right, I got my pertinent flight info. I got to go get the boss later. So can't forget the boss. You'd be in trouble. Okay, so that's that one. So again, this is a very common mistake. It's very easy to make. When am I shifting left, right? When am I shifting up, down? So when I'm shifting up, down, I'm almost just looking for a number that's not even involved in like the action. You know what I mean? If that makes sense. It's just kind of hanging out at the end, right? So like if you looked at this example, right? That +3 is kind of, he's just hanging out at the end. The same thing if I look at this one, right? That -4 is just kind of hanging out at the end. In this example, right, there's really nothing kind of hanging out at the end. It's sort of it's having a party in the fraction with everybody else. So that is the technical way of explaining things. Okay, let's go on to the next one. I think the next one should be easy. Oh, no, almost. It's a slight modification. Oh my gosh. 55. 55. Okay. So maybe you can help me on this one. What's going to be the difference between this one? A couple differences. I would say 3 differences between this one and the last one. So can you pick out the 3 main differences? Let's see. So I think so maybe you're missing an exponent, in which case you're thinking about vertex form. Am I on the right one? This one I don't think we'll need vertex form because that would be for a quadratic. So I think maybe we don't need that in this case. So I'm thinking about, again, kind of in terms of the parent function. Who am I manipulating? You know, sort of what graph am I starting with in this case? What graph do I want to start with? And instead of 1 over x, in this case, I'm going to start with 1 over x squared. Yeah, phasor, so that's certainly going to be part of it, the negative part. So I think, man, 1 over x squared, what did that look like? Because my algebra teacher said I should know it. Did I do that one? Oh, no, I didn't do that one. So we left it out. Okay. No, we did it. Okay. So there's 1 over x squared. So that's the graph I've got in my head. I'm thinking, you know, it's this thing. And that's what I'm playing with in terms of moving things around. Okay, so let's do this. So I can see a couple things that are different for sure. As Phasor pointed out, there's the negative. That's going to change things. We picked out the square. We said, okay, that's going to be, for example, that's going to be a different graph than 1 over x to the first. That's what I'm trying to really say here. Okay, so I recognize the basic graph, so that's good. And then we have the negative, and then I see this -2. So I'm really thinking, what does the minus do? And what does what does the negative and the numerator do? And what effect does replacing that x with x minus 2, what 2 effects are that going to have on that 1 over x squared, on the graph of 1 over x squared? And maybe I would, again, first start with 1 over x minus 2 quantity squared. You know, what would that do to my original graph? So again, I see that -2. I'm thinking it probably has something to do with up, down, left, right. Right? Up, up, down, down. Left, right, left, right. Keep going. Right? BA start. Okay. So in this one, that x minus 2, and one thing you can think about is, you know, if you think about 1 over x squared, where is this undefined? Right? This is undefined when the denominator equals 0, which is when x equals 0. I'm kind of doing that same thing. Well, notice this new one. This is going to be undefined at x equals, well, what's going to make the denominator 0? Well, I think x equals 2 is going to make the denominator 0. So that already tells me this place where originally it was undefined, along the y-axis, that's where originally it was undefined, that's now going to get shifted over. So I like to do this kind of thing if I'm unsure, because that usually gives me, like if you were totally unsure, that should give you at least a clue, a quick clue on which direction you're going. And it should be a really, I think, effective one. Okay, so now it's undefined at 2. So, but otherwise it should have that exact same shape. And since it's even, And again, you could plot some points on that. Now, the only other thing we have to do from that is look at the negative of that. And I'm going to pull the negative out front. It was in the numerator, but that doesn't matter. We can put it in the numerator. We can put it in the denominator. We can put it out front. So last but not least, what does the negative do? Well, again, we saw that. It reflects about the x-axis. So in this case, we're just going to get that same graph. So it was undefined at x equals 2. That's where we said it was undefined. And now it's just going to be flipped. So it'll go that way, and it'll go that way. So that would be your graph. Again, a real cruddy, rough graph of it. But I can get a lot of information from that graph. So that is useful. Okay. 2 left. Okay, don't be disappointed. I can hear the disappointment in your voices. So maybe 56, I'll even let you do this one because I think it shouldn't be too bad. Maybe I'll get us started. And you can tell me what you think. So again, in this one, I would think, well, the parent function that I'm shifting, right, the parent function is going to just be the absolute value function. So then I would think a couple things. I would do it probably in a few different steps. The first step, again, I would sort of look at the most inside. So I would look at the absolute value of x plus 1. Well, again, it's on the inside, so this is going to shift it left or right. And since I see a plus 1, it's going to shift it left 1 unit. That would be the first thing I would do. The next thing I would account for is that negative. And again, what it's doing when I say, when I'm listing the step, right, I'm basing it on what we had right before it, not the original parent function. So I'm saying, okay, the absolute value of x plus 1, we take, we shift, let me write it better. Shift the absolute value of x left 1 unit. Now at the next step, I'm obviously manipulating the absolute value of x plus 1. I say obviously because maybe it's not obvious. I just want to clarify that. So again, this is now going to reflect about the x-axis. Boom. So I've just moved it 1, and now that v should be opening down. And the last thing that we have to do is now if I look at that minus 2, and again, that minus 2 is just kind of hanging out there by itself. That minus 2 is now going to move it down 2 units. So I think that should give you a pretty quick rough graph there. Okay, last but not least, I think this would probably be the worst one. And hey, it looks like it's the grand finale. I know I didn't do anything with exponents in here. Again, I figure if you are going on to calculus, you should be pretty solid with exponents. So I hope that's why it's left off here. And if you're not, I'm not saying, if you're going into calculus and you're not good with exponents, absolutely you gotta know. Be careful. Be sure you can factor, a bunch of stuff. So this one's a little tricky. And the thing that's tricky about this one is it daylight there? Yes, very much so. It's just a touch afternoon. Yep. So very much daylight, very much hot. Typically when you do shifts, What's the best way of writing it? Okay. Well, I know how I want to write it. Okay. So if you have something, if you take f of x and you replace that with f and you multiply all the x's by something, by some value k, this is going to compress it if your k value is greater than, if it's greater than 1, and it's going to stretch if your k value is between 0 and 1. Now you can think, well, Patrick, what if it's negative? The negative, if it's on the inside, it's going to actually flip it about the y-axis, right? Here we have negatives on the outside, but f of negative x is going to reflect it about the y-axis. So that's something I'm not touching on heavily. There's not an example of that here. Do be aware of that. Okay. So I'm going to rewrite this one. This is kind of the clever part a little bit. This is the part that I think would bother people. So if you have a coefficient in front of x, and in this that's not a positive 1, which in this case we do have a 2 in there, right? I need to rewrite this. And the way that I'm going to rewrite this is okay, so there's my parentheses to the third power. There's my original set of parentheses. So here's kind of the magic. Okay, so here's the magic. The way I'm going to rewrite this is 2 times some quantity. And I want, when I distribute, I want to get 2x minus 1 back. I want to get that, and I want to get this back. Well, 2 times x would give me 2x. I would need a minus 1/2. Because 2 times negative 1/2, that's going to give me my negative 1. That's going to be my algebra rewriting. I think, was that the entire question? Was there anything else on there? No. That is the entire question. So this is the thing that I'm now going to graph. So I'm going to try to graph. So I'm thinking about, it's equivalent. I'm thinking about graphing f of x. If somebody had written it in this form, I would say, aha, this is better. But sometimes they may not give it to you in a nice form. So I think, what does this do? Well, the parent function, that to me, I see something being cubed. I see an x to the third power, and then I see some numbers in there. So I think the parent function is going to be f of x equals x to the third. That's what I'm starting with. And we said x to the third looks like that and like that, roughly, just to remind you. So I'm going to, again, do it in 3 steps, inside out. I'm first going to graph x minus 1/2. Oh, I think okay, I need to be more careful there because my arithmetic is, no, okay. Yes, this looks good, okay. Okay, sorry, I thought I messed up for a second. Okay, the first thing I'm going to do is graph x minus 1/2 to the third power. The second thing I'm going to do from that is then do this compression. So those are going to be my steps that I do it in. Okay, almost there. So this x minus 1/2, I'm replacing the x with a negative 1/2. Well, I see a minus 1/2. This is going to move it to the right 1/2 of a unit. So originally it went through 0, 0. It's now at 1/2, comma 0. So there's that, and there's that. And again, you could plug in x equals 0. You would get negative 1/2 to the third power. So I know that that point, that y value is going to be negative 1/8 if I want to plot that. Okay, so I'm just taking x to the third, shifting it. I see, oh wait, I wrote to the right 1/2. Okay, perfect, okay. And I moved it to the right 1/2 of a unit. So I noticed that original point that was down here got moved over here, and that is this point. Thought I messed up for a second, but this looks good. So the last thing I want to do is this compression. So this is kind of the first graph. This is my second graph. Bada, bada. Okay. So what this is going to do is this is going to, shouldn't the cube be in there? Did I miss the cube somewhere? Oh, thank you. I need the parentheses is what I need. Um, thank you. I left off the set of parentheses. That is very important, if that's what you mean. Absolutely. Yes. Okay. So now what we're going to do is we're going to compress. So we're going to compress everything by a factor of 2. So equivalently, it means that every x-coordinate is going to get, its distance to the x-axis is going to get cut in half, is what's happening. So this 2 inside of there, and we can plot some points to make sure this looks good. This 2 is going to take, so the way you can do it is take any point on the graph, any point, take the original x-coordinate, and we will divide by 2. And leave, okay, this is not good English because I've got like 80 semicolons in here. Leave the y-coordinate alone. And in that vein, why not include one more semicolon? Okay, so we'll leave the y-coordinate alone. So for example, this point at 0, -8, if we take the x-coordinate, which is 0, and divide it by 2, it's still 0. So that point is still going to be down there. That hasn't changed. That point that was at 0, -1/8, still there. Now this other point, though, we've got this point 1/2, 0 that was on there. If I take the x-coordinate and divide it by 2, instead of being at 1/2, it's now going to move even closer. Instead of being at 1/2, it's now going to be at 1/4. Again, the y value is the same. And then it would still have that basic shape to it. So this would now be my final graph of 2 times x minus 1/2. Thank you, phasor, all raised to the 3rd. Yes. Yeah, the good thing is you won't really see too many of these. The place that you'll see these types of compressions in calculus, okay, I swear I don't mean to use the semicolons. You will use compressions, I would say mostly, I'll say mostly with trig. Oh my goodness, my stomach's growling. You'll mostly see these with trig functions. So for example, there's maybe y equals sine x, right? It's not supposed to get bigger. Let me do a better graph of y equals sine x there. So Jabba. So there's y equals sine x. If you looked at, for example, y equals sine of 2x, that's all going to get compressed. So one little cycle is going to happen much faster. It'll go up and go down much faster, go down and back up much faster. So here we got 1. We should get much more. You should have gotten a whole cycle in that distance. So maybe let me chop it in half. So let's see, this would be from 0 to 2 pi to get one little, oh my gosh, this is not correct either. This would be from 0 to pi, oh my gosh. So this would be from 0 to pi over 2. It's now going to get compressed in. This would have been pi over 2. So this would be pi over 4. So the idea is it's going to get smushed in, is what I'm trying to say. It's going to oscillate much faster. And likewise, suppose we had y equals, say, sine of, instead of 2x, say 1/2 x. Well, in that case, it's going to stretch it out, make it much more lazy. So bada, bada. Okay, again, not to scale, but that's the idea. It's going to stretch it out if the number is between 0 and 1. And if it's larger than 1, it's going to smush it together. So I think that's the last one on there. Is that it? I think that's it. So I think that's it. Okay, so maybe a trick review. I don't know. We'll see. I may do one. If there's interest. Again, if you feel like throwing an old dog a bone, if you liked this, I would certainly say, hey. You can just rewatch the video, Bibik. It'll be there. It's on there. Rogalski. I don't think he's Russian. That was the calculus guy. Just search popular calculus textbooks. You'll find him. So if you want to throw a dog a bone, there I am. No pressure. I don't care. I do hope you've enjoyed the videos. I have purposely made all these live streams advertisement free. The replays are advertisement free. So I know everybody gets bombarded with ads these days on YouTube. It's how I make my pennies, and it really has turned into pennies. It's not, but that's okay. So if you want to help support the channel, Patreon's probably the best place to do it right now. If not, no worries. I'm not worried about it because I'm here just because I enjoy doing it. So, all right, my friends, I guess that's about it for me. Any questions, comments, concerns, thoughts before we part ways here? And maybe we cross paths again, and maybe not. And if not, it's been a pleasure. Queen Bee, Phaser, you all have been here for the long haul. It's been an absolute pleasure. If you see me in real life, I will expect a fist bump or a high five at a minimum. So, yeah, my pleasure. I hope it helped you. If I make it to Chicago, you gotta keep an eye out for me. So, all right, my friends. Well, then enjoy your day. Yeah, no problem, Alpha. So, all right. Well, everybody have a great day. And so I don't have much for kids. I've thought about doing them, but I haven't yet. I do have arithmetic for sure. I mean, I have fractions, but again, it's more geared towards like an adult that needs a review on fraction. Like there's no pictures of kittens and cats and songs and dances and stuff like that in my fraction videos. It's more like, it's like if Patrick needed a review on fractions. I don't want to see songs and cats and wizard hats. I want to see somebody showing how to do fractions. So yeah, it's in there. A kid may not find it exciting. If you're looking for something kid-friendly, a little more in that vein, there's certainly stuff out there, absolutely, for sure, that you can dig around. I do not have a specific channel at the moment to recommend. I've thought about doing slicker production stuff like that. I don't know. I don't know if you want to watch it. It's time-consuming to make, but that's more than you wanted to know. So, but if not, there's definitely kid stuff. For sure. It shouldn't be too hard to find. So anyways, okay, my friends, I hope it helped. It's been fun. We've done it for a few days, and I hope it's been helpful, and I hope you find some use in it. If you do have any suggestions for maybe what can make things better or improvements, or just say, hey, I thought it was pretty good. Keep on keeping on. That's useful to me as well. So, all right, my friends, enjoy your weekend. If you're going back to school, good luck. And I will be here floating around. So take care, everybody. Have a great day, and I hope to see you again soon.